Good morning and welcome to April 28th. Yes, Tuesday, April 28th.
To Stars for Stars legend, wait for it, Dairy Learner Show. Brought to you by the amazing Mrs. Smith.
Thank you. Thank you. Just want to start by I miss you all and I wish we were in class together, but since we can't be, I am glad that we still have this. And I am still glad that I get to see you all on a regular basis. So let's go ahead and start today. And again, we're talking about patterns in the multiplication table. So you'll see on my notes for today, and I'm going to scoot this over just a little bit so that we can see we're talking about patterns in multiplication. Remember, this is our multiplication sign, our time sign. So when we're looking at our multiplication table, and right here, we're only looking at, usually we look at a multiplication table that will go to 12 on each side, and it starts with X. This one goes to 10. So let's look at our first example. It says, use the multiplication chart to decide which of the following statements is true. Says, all of the multiples of 3 are even, all of the multiples of 7 are odd, all of the multiples of 6 are even, and all of the multiples are 9. Well, if we go back to our notes from yesterday and we look at the multiple is the product of any number and another whole number. For example, if we look at our products, and it says the multiples of 3. So let's think about the multiples of 3. If it says a multiple is the product of any number and another number, so that would be like 3 times 1 is 3. 3 times 2 is 6. Those are both multiples of 3. 3 times 3 is 9. So if we look at this entire, so are all the multiples of 3, are they even? Think about 9. 3 times 3. 9 is a multiple of 3. Is it even? No. So let's look at B. Well, let's write down some notes. And this is example 1. So if we look at multiples of 3, be like 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and 33. Well, A says that these are all even. Are these even? No. So let's look at B, multiples of 7. 7, 14, 21, 28, 35, 42, 49. Keep going. 56. You're doing great. 63. Ooh, I don't know what that was. 70, 77. And it says all the multiples of 7 are odd. Is 7 even or odd? Even. I mean odd. Good job. 14, is that even or odd? It's even, so B can't be a choice. So let's look at C. The multiples of 6 be 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66. And it says all the multiples of 6 are even. 6, 12, 18, 24. Do we see any of these numbers that are odd? No, so that's a possibility. So let's look at the multiples of 9. 9, 18, 27. Remember, if we're doing multiples of 9, we can add 10 and subtract 1. 9 plus 10 is 19, minus 1 is 18. 18 plus 10 is 28, minus 1 is 27. 27 plus 10 is 37, minus 1 is 36, and keep going. And it says all the multiples of 9 are odd. 9, even or odd? Odd. 18. That's an even number. So C would have to be our answer. Okay, and look at the shaded boxes. What do you notice about these? Well, if we look at the shaded boxes, we will see 66, 69, 72, 75, 78. What do you notice about each of these numbers? What do you notice about the difference between 66 and 69? What did they have to do to get from 66 to 69? Great, we added 3. What about to get to 69 to 72? What would you have to do to get to those numbers? 70, 71, 72. So we added 3. 72 to 75. What would you have to do? Exactly. Add 3. And then to get from 75 to 78, what do you need to do? Great job. Add 3. So if we look at the shaded boxes, what do you notice? They increase by 3. So what would you expect the next number to be? What next box would be shaded? What would we need to increase 78 by? What is our pattern? We need to add 3. So 79, 80, 81 would be our next number in our pattern. Doing great, boys and girls. What patterns occur in the multiplication table below in the shaded areas? Now, I want you to take a minute. I want you to pause the video, take a minute to figure this out so that then we can go and check it together. Okay? I hope that you've either paused me or that you've completed the question so that when we go over it, you're checking yourself to make sure that you answered it correctly. All right, boys and girls. It says the sum of the digits in each number is even. Well, let's look and see what they have first. They have what? These are all the multiples of. Great job. If you notice from earlier, they just listed the multiples of 9. 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99. Then it says the sum of the digits in each number is even. Well, what is the sum of the digits for in each number? Well, that would be like 9 plus 0. That's 9. Is that even? No. So let's look at A. The sum of the digits in each number is even. So if we look at 9, that would be like 9 plus 0. That equals 9. That's not even. Or the sum of the digits. 1 plus 8 equals 9. 9 is not even. 2 plus 7. See, like 27, the sum of the digits, 2 plus 7, that equals 9. That's not even. So A is not a choice. Let's look at B. Says each number decreases by 9. To get to from 9 to 18, do we decrease by 9 or do we increase? Think about decrease. When you decrease something, it's getting smaller. When you increase, like if I increase my bank account, it's getting bigger. So B says each number decreases by 9. So if I decrease it by 9, then my next number would be 0. Well, that's not true. So let's look at C. Each number increases by 9 and then decreases by 10. So if we look at 9, it says it increases by 9. 9 plus 9 is 18. And then decreases by 10. Well, if it decreases, that means that 18 minus 10 is 8. Is that our next number? No. So let's look at D. Says the sum of the digits in each number is equal to 9. Well, let's test it. The sum of the digits. So that would be 9 plus 0, because there are no other digits, correct? Equals 9. That's true. The sum of 18 would be, the sum of the digits would be 1 plus 8 equals 9. That's true. 27, if we look at the sum of its digits, 2 plus 7 equals 9. That's true. Let's look at 36. The sum of its digits is 3 plus 6. That equals 9. 45. The sum of its digits would be 4 plus 5. That equals 9. And I bet you if we keep going, it would be the same pattern. So our answer choice would be D. The sum of the digits in each number is equal to 9 because when we add up each of these, they equal to 9. Which expression can be used to find the missing number? This is a time. Go ahead and pause. Take a minute. This is example 3. Go ahead and look at it on your own. I'll give you just a minute. All right. Now, if you have not finished, go ahead, keep me pause or pause me so that you can check yourself. It says, which expression can be used to find the missing number? So what they're really asking us, are we adding by 9 to get the numbers? Are we subtracting by 9? Are we adding 9? Because it says 45 minus 9. That'd be 36. Well, that doesn't go there. 63 minus 9, or 45 plus 10. So if that was 45 plus 10, that would mean that 55 goes here. So really, if we're looking at this, I have two plausible answer choices. They're either increasing each by 9, or answer choice C, they're decreasing by 9. Well, if we look at this, to get from each of these, 81 to 72, I subtract 9. 72 to 63, subtract 9. Which means that my answer choice would be C, that I need to take 63 minus 9 to get the next number. All right, boys and girls, we miss you, and I hope you enjoyed the video today. I'm sorry I cannot do cartwheels, Penny McAdams, but I miss you all. And don't forget that these are just the slides that we went over to help you in case you have any questions. Your independent work today is your form, the student copy of Tuesday, April 28th, independent classwork, Google form. Bye, boys and girls. I'll see you later on. Have a great day.